Hi guys, Rex here. Today I want to do a video on engine ports, and we're going to look at how many ports and what the ports do, and why is a 3 port better than a 5 port or 9 port, and we're going to talk about those specifics. So um, that's about all the introductions. Let's dig into it. Okay, Rex here at RW Mods. Today I want to do a video on ports and what the number of ports mean and what they do. Here is a 3 port, 4 port, 5 port, 6 port, 7 port, and 8 port. Yes, I have a few junk engines laying around. Actually, this is one I just happened to be working on this week, and it's a 6 port, and I haven't seen a 6 port. Not that I remember. I haven't seen one for a long time, so that's an old one. I have this cutaway thing. I want to do a video on how an engine works and stuff, but that's a little more involved video, and I don't really have time right now to do that whole production of that. But we're going to use that to look at some things here. So look at the cutaway. So first of all, just kind of manufacturers a few years ago would more often than now, they would kind of have their budget engine as a 3 port, or their low end, low power band engine as like their 3 port, and then their 7 and 9 ports would be like their on-road engines, or their high end, high RPM engines. And generally thinking, if you're gonna have a truggy, you should run like a 3 port, or but that really isn't the case. It can be, like years ago, I'm talking like 20 years ago, you really couldn't use a 7 port in a truggy or something that you needed a lot of low end power, or even in off-road. That was, the 7 ports were more for on-road and stuff. But today, it's more the manufacturers are making more engines that don't really suit that old kind of thinking. And it really doesn't really matter how many ports you have to make a good engine. There's reasons for different things, but and these are all just my theories and my opinions on this. Yeah, you might have a different opinion, and that's fine too. But this is just my background and my bringing up. So I often get the question. So someone sends me a 3-port engine, and they said, "Can you make it into a 7-port?" And the answer is definitely no. Now, it isn't impossible to add a port, but it is. If you're looking at, say, this 8-port, it has 8 smaller ports. So this one has 8 smaller ports, and this one has 3 big ports. Well, you can't just add ports in between those, because it has to be within this range. You can't just add a port up here or down here and stuff. So that's why you really can't add ports, is because the higher number of ports generally means more ports, but they're smaller. So that kind of answers that question that people ask. Now, it is possible to add a bypass port. So the bypass port, I'm going to grab a piston down here. So we'll go over now this is a 5-port. So you have 1, 2, 3, 4, 5. And oftentimes these used to be labeled as a 5+2 because it has 2 bypass ports. Now, these aren't actually ports that let air into the engine. These are bypass ports that let air out from under the piston and stuff. So that's not considered a port. And then there's the exhaust port, which it isn't counted in the number of ports. So when they say it's a 5-port, it does have a 6th port that's the exhaust port, but that's not counted. It's only intake ports that they count. And I guess we'll kind of get the cutaway engine here. And as the piston travels down, then this is an intake port. So the exhaust port is over here, and that is exposed first. You see that gets exposed first, and that lets the air out. And then as the piston breaks the plane there, so the piston is going down, so it's putting pressure the whole time. When it's going down, it's putting pressure, crankcase pressure down here. And when it gets to that point, then air rushes in the channels in the block, and it starts, as soon as it breaks that plane, it starts basically kind of pumps air up into the cylinder till it gets to the bottom, and then you're in the compression stroke. So I just wanted to show that a little bit quick. Like I say, I'm kind of excited to do a whole how an engine works in a later video. It might be a little while, but so the number of ports really isn't as important as the timing of the ports. So when the exhaust port opens, the height of this, if you move this up, a 0.5 millimeter, it's gonna really affect the top end and reduce the low end and stuff. So the number of ports isn't as important as the port timing, the exhaust port width. These are all kind of, if you look at this, the exhaust port width on this 3-port versus this one has a 3-port exhaust. Still not counted on the intake ports, but it has this, the center, and the outside for exhaust ports. So that port wraps all the way from there, the exhaust port. So it's gonna flow the exhaust more than the small wide exhaust port, which can be good and bad. It's this smaller exhaust port's not going to expel the gases as much. So typically, I think more for top end power, they go with the exhaust, the wide 3-port exhaust. I tend to find the at least in off-road, the 3-port exhausts tend to be a little bit more hungry on fuel, a little harder to get fuel mileage. And that's always part of it too, exhaust ports and timing. So this is a typical 3-port. I believe this is a VZB V-spec, pretty old engine. So typically the more budget engines will have a 3-port. Now this was a good engine in its time. It wasn't a budget engine, but typically a budget engine, it's easier to, they use a little end mill and cut these ports in, and then they got to cut the chamfers and bevels on them and stuff. So it's cheaper to manufacture when you have to just do 3 ports versus let's do the 7-port. Do these all little intricate cuts. It takes more time than just doing 3 holes, and especially the exhaust too. It's a smaller bit to cut that. With this one, it's even smaller bit to cut some of these small holes and stuff. So that it takes probably take 4 times as long to machine just the ports on this one versus this one. So that's part of it too, is the cost of manufacturing. And I guess I'm not really sure why the on-road engines are. I don't have any 9 ports, but I've heard, I've worked on some 9 ports and stuff. But the more on-road and higher RPM engines tend to have more ports, and part of my philosophy on that might be that you got more RPM, the piston's going up and down farther, and it's just a more stable block because it just has a bunch of small ports versus this. The only thing kind of in between here, there's really nothing in between there. So you only have support here. It's in 4 spots, where the other one you would have twice as much support just in a smaller area. Kind of my philosophy on that, but. The port timing, going back to that, if you were to move this port up or down, really affects the power band, or the exhaust port up or down, or the relationship between the degrees between. When I talk about the blowdown, when I do my reviews and stuff, that's the time that the exhaust port opens to the time the intake port opens. And you move that exhaust port up, that's more degrees between them. So the port timing is very critical. The number of ports really isn't. So let's look at each one of these. We looked at that 3-port. This is a Novorossi 4-port, like a BTT. Is that what it was? The Mito 4. They have a few 4-ports in it. I kind of like the 4-port versus the 3-port. It offers a little more support to the piston. A little bit wider exhaust port on this one than the 3-port. But this one just has the 2 transfer ports on each side, and then the boost ports are generally, I guess I didn't talk about that. So the ports on the side are your transfer ports. The port on the back side, away from the exhaust, is the boost port. And so this 4-port is similar to the 3-port. It has 2 side transfer ports, and then 2 bigger, or two boost ports. This is the other one was an Novorossi. This is a Alpha 5-port. Pretty good sized exhaust. 5 transfer ports, and then this one has the bypass ports. And this is just an Alpha thing. They'll put a cut in there. It does kind of affect flow going up to that boost port. So that's a pretty typical 5-port. I just showed you this 6-port. It's basically kind of like a 5, or yeah, it'd be like a 5-port engine. If this was just the boost port was just one big port, it would be kind of similar to a 5-port. So 2 transfer ports. And so this is the 7-port, pretty typical. What kind is it? I think this is a Novorossi 7-port. This one's got some modifying done to it. I don't think that's, if it's mine, it's pretty old, but this one has the 3-port exhaust. A lot of the 5s, the Novorossi 5-ports had this long, well, the transfer port, I don't know if they have a name for this, but it is a transfer port. They're typically long, but the piston only comes down to the bottom of the ports here. So the rest of this down here really isn't doing anything. I don't know why they do that. It does kind of help, with flow, because there's nothing restricting on the bottom, but the piston only goes down to the bottom of the port, so it's not really doing anything past there. So, but a typical 7-port has the long skinny port, 2 transfer ports, the boost, and then the 2 transfer ports on the other side. And this is an 8-port. Typically the higher end engines, the more RPM engines, have the 3-port exhaust. And then we have kind of that long skinny port, not quite, it's a little bit skinnier. Kind of a bigger transfer port. And these are our boost ports here, but they kind of add a port in between. I don't know if that has a name either. So, and then this one also has the 2 bypass ports, but they're pretty small. So that's an 8-port. And I don't know which, this is a Novorossi sleeve. I don't know which particular engine this came off. Years ago when we were racing, we raced a Novorossi 421B, and it was an 8-port, and that pulled the truggy really good. It ripped. It had really good bottom end, and that's kind of when I realized that the number of ports really didn't matter on the power band, or the use of it. It's more in the porting and the timing and stuff. I guess I did talk about the bypass ports. I did talk about the bypass ports, and that's not counted as a port. Usually they say the +2, but the bypass ports, if you see, the piston comes down, and as soon as that piston reaches that plane where it opens up, That's when air starts going into the cylinder inside. And if you can see, the air underneath the piston can travel out that hole. So the piston's coming down, it's pressurizing underneath the piston, so you're getting pressure in the crankcase, and then as soon as that opens up, and then it continues until it gets to there. So that hole lines in the piston lines up with the hole in the sleeve to let a little air out from underneath the piston. And I always thought they kind of gave it a little bit more like snap on the bottom, or rev quicker. I've never really done like a comparison between the same engine with and without it. I haven't done that, but I have cut these in before. Not too often. It is kind of a pain because you got to deburr the inside, and it's kind of a little bit tedious and not really worth the effort. And a lot of engines nowadays really aren't. This is a fairly new 4-port engine, within the last 5 years, and they've just, Novorossi and other companies have just kind of done away with putting in that bypass port, and the engines run pretty good. I kind of like them, but it's not really, doesn't really affect it in a big way. I do kind of like that it has it in the piston, because it does lighten the piston a little bit. That's a little bit of rotating or I guess not rotating mass, but it's a directional mass. So let's see, what else can we talk about in ports? So yeah, I talked about pretty much everything. Like I said, I'm going to do a video with this cutaway engine on the whole thing, how an engine works, but also dealing with the ports. As I'm talking about that, as a piston comes down, it pressurizes the crankcase. So any amount of volume you take out of the crankcase kind of decreases that pressure. But so if you do a lot of modifying in an engine and take a lot of grinding and different things, it does decrease the pulse as the piston goes down, and the pressure that builds up to go into the ports. And there is some different things you can do with the boost port, because that's straight across from the exhaust port. So we got, let's grab this one. So you got the boost port. The height of that kind of makes a little bit of difference on how you kind of want the engine, the air to kind of swirl up over top and kind of push the exhaust out because as the piston comes down, you want to kind of swirl that air in there so it goes out the exhaust. And there's some different theories, and that's why pipes are so important. Getting the right pipe, or running, especially like someone runs without a pipe, there's no back pressure to hold that, the exhaust just open to the world. If you don't run a pipe at all, if you don't run a pipe at all, then it's hard on the engine or whatever, because there's no back pressure, and actually probably get more raw fuel out. The exhaust pipe has a lot to do with the power band and the fuel consumption and all that too. So basically, I guess thing to take away from this is the number of ports have less to do with the power band of the engine than the engine design and the timing between the ports. So your transfer ports, and the height of these ports has more to do with the size and shape of the ports. And there is a little bit to, let's see which one, the 4-port. That's what we got. I'm all mixed up now. This, and getting into modifying. See, this port here has a nice little cut here that kind of directs that air, and that's what I'm talking about, a swirl, kind of getting a swirl around and then to the exhaust. But this is pretty sharp here. So beveling the ports like this all the way across does change the power band some. So yeah, as a modifier, I mean, when I first started modifying, I just did some cuts and that was it. You know, this one's probably a pretty typical something I did a long time ago. You know, just add some cuts to kind of direct that air in there better. Especially here, you had this and you know and all that. So kind of directs. It's less in the way of when the air is going up because it's coming up from the bottom. But um, but generally that doesn't affect it in a great manner. The port heights, you can do all the grinding you want on an engine, but if the port timing and the exhaust port height and the transfer ports, you know, your timings are all off, it's not going to run right. So this only affects just a little bit of fine tuning. But this one you know, this is pretty sharp here where a lot of these are beveled. This one's actually kind of a nice mod. It's a nice little for the air to direct there and stuff, but not overkill. The that does affect it, but not nearly as great as the exhaust port and transfer port heights. Well, I hope you learned something today. I think that's about it I want to go to, and probably going to be able to, you know, a little while before we get the whole video. I don't even know how I want to go about this whole video yet. I got the engine kind of done and ready and stuff for a video, and we got a carb cutaway and stuff and everything, but we'll do that at a later date. But if you have some ideas, leave them in the comments. What you'd like to learn. You know, we're gonna go through the whole, you know, what the timing does, what the, you know, everything in the engine kind of, what from the carburetor all the way to the exhaust, we'll go through how that all works. But if there's any specific questions, leave in the comments, and I'll try and you know cover that when I do this review, or not a review, but it's a detailed on how the engine works. So thanks for watching.